Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Moving Charges and Magnetism came in a year JEE 2025. Okay, so let's go through the question. The question is, a proton is moving undeflected in a region of crossed electric and magnetic field at a constant speed of 2 into 10 power 5 meter per second. Now, when the electric field is switched off, the proton moves along a circular path of radius 2 centimeter. Now, the magnitude of electric field, what is given? X into 10 power 4 Newton per coulomb. They are asking the value of X is how much, and the mass of the proton is also given in a question. Okay, so here the concept of little bit Lorentz force will be used. Lorentz force, that means when a charged particle is moving in a combined electric and magnetic field, the resultant force is called what? Lorentz force here. Okay, so here I have taken here the two situations. Now, so here this is the magnetic field I have represented by the cross. That means magnetic field is inside the board. Okay, that means along a negative z direction. Is it basics here? This is x direction, this is y direction towards your screen z axis, inside the board negative z axis. That's why I told you magnetic field inside the board, negative z direction. Now what will happen right here? Let's take the charged particle is moving in this direction, along the x direction, along the horizontal direction. So you know the formula is what? I'll write here one formula, vector F equal to Q into V cross B. Is it right hand thumb rule? Okay, so according to the right hand thumb rule, even you can use Fleming's left hand rule, also not a problem. So according to this rule, what will happen that here, when the charged particle is moving along x direction, magnetic field inside the which direction? Negative z direction. Then according to right hand thumb rule, curl the fingers of right hand from V to B, that means thumb is upward. So this proton, that means positive charge, will experience magnetic force upward here. Okay, and now it is going undeflected, straight line. That means anyhow moving with a uniform velocity, net force should be how much here? 0. So what will happen? There is the one electric field downward direction. So anyhow the proton is positive, positive particle is there. So the electrostatic force will be along the direction of the electric field. So here you can see Fm and Fe both in which direction? Opposite direction. They will cancel out each other, net force 0. That means they will keep on moving a straight line here. Okay, so in this situation what will happen that here, for the undeflected movement, or we can tell here moving in a straight line, both the forces will be equal. Fm how much here? We can write very well, see QVB into sine 90 degree, because the angle between velocity and magnetic field how much here? 90 degree. Velocity along x direction, magnetic field negative z direction, and this is what here? Electrostatic force QE. And here you can see very well, I am teaching with the very basic, QQ cancel. So from here I can write here the value of magnetic field B, I can write here E by V. Why I am writing this? Because later this magnetic field we have to eliminate, and here we have to tell the electric field. Okay, so I am writing B equal to E by V. Now this one thing is done here. Now, this is done. Now what will happen that here? This is the situation 1, case 1. Now in case 2 what happened? Suddenly this electric field is switched off. So when this electric field will switch off, what will happen that here? There will not be any this electrostatic force. Okay, so in this situation what will happen that here? Only magnetic force will be there. Which force? Magnetic force is there, and anyhow velocity in this direction. Okay, so you can see very well this magnetic force and velocity is making how much angle? 90 degree. How much angle? 90 degree. Okay, and one more thing we can tell that here, even velocity and magnetic force I told 90 degree here. So in this situation which kind of path will be there? Circular path will be there. If in case everywhere magnetic field is there, so it will make the complete circle. Here I have shown magnetic field only in this region, so I have drawn only this much arc. Otherwise if magnetic field is there, it will complete the path, circular path, not a problem. Okay, so let's take here the circular path or circular arc, whatever. The center is here, so this is the radius is there. Okay, here what will happen that here, from the basic, if I will tell that, here what will happen that here, this magnetic force will act as a centripetal force, because it is moving in a which path? Circular path. So here what will happen that here, this magnetic force will act as a what? Centripetal force is there. Okay, so we can tell very well magnetic force anyhow QVB sine 90 degree. Centripetal force formula what is there? mv square by r. So from here I can get very well, thus R will come here mv by bq. Now what will come? R equal to mv by bq. Now what will happen that here? This B value from here I will put here. So when I will put here the value of B, what this will happen that here? Kindly see here, R equal to B is E by V. V will go upward, so it will become here mv square by Q into E here. Now because B equal to E by V, R equal to mv square by QE. And what we have to calculate? We have to calculate here the electric field. So just let's make the formula here, the electric field formula. From here it will become here mv square by QR. What is coming here? It is coming here mv square by QR, and this is anyhow the main formula, mv square by QR is there. Now after that here, if I talk about here the masses, anyhow this is the mass of the proton only. No? What is this? The mass of the proton is there. So mass of the proton is given here. Okay. V, what is given here? This is the V, 2 into 10 power 5 meter per second. What is the R? Radius also you can see very well, it is given here the radius 2 centimeter. Now that means 2 into 10 power minus 2 meter. Okay, and charge of the proton you know very well. So all these values I am just going to put in the next page. Can you see very well? Okay, so I will just write now here. So we know very well here E equal to m V square by Q into R. Again I will mv square by Q into R. Okay. So mass of proton anyhow 1.6 into 10 power minus 27. Mass of the proton is there, okay, MP is. So 1.6 into 10 power minus 27. Is it? V what is given here? Kindly check here. The V value is 2 into 10 power 5, but we have to make it here square. So it will become here 4 into 10 to the power 10. Charge on the proton 1.6 into 10 power minus 19, and radius how much? Just see here, I think so 2 centimeter only na. So 2 centimeter. So 2 centimeter means convert into SI. So 2 into 10 power minus 2 meter is there. Now we'll cancel the things here. 1.6 cancel, 1.6 cancel. This will become here 2 2s are 4. Okay. So I can write here, see 2 into 10 power minus 27 into 10 power 10, and here minus 19 minus 2, 10 power minus 21 in a denominator. When it will go in a numerator, it will become here 10 power 21. Okay. So when you will simplify this, it will come here 2 into 10 power minus 27, and here 10 to the power 31. So it is coming here 2 into 10 to the power 4, and anyhow this is the electric field Newton per Coulomb here. Kindly see very well how we have done the calculation. Is it? So 2 into 10 power 4 is coming here. But here what is given here? X into 10 power 24 here. Now electric field is coming what? 2 into 10 power 24 Newton per Coulomb. So when I will do the comparison, here you can see 2 is there, and here what is there? X is there. So what is the value of the X? The value of X is 2. Okay. So here I will write here the 2 very easily. Is it? So students, I hope so. This question based upon the Lorentz force and the circular path of the charged particle is very clear to you. Keep studying, keep going.